Good evening, everybody. Could you all let me know if you all are hearing me? You all can reply in the chat. All right, so I see Emily says she's hearing me. All right, so we're gonna start, right? Whoever comes in late, they can join the class. I will also, the class will be recorded, so you all can review the class when you're able to. All right, just check something here. So we have Ryan, Danica, Sharice, Tamika. All right. Okay, so right now we're gonna start. Last we were working on was statistics, right? But because of the situation, I won't be starting the past papers on statistics as yet. What I'm gonna do, I'm gonna start relations, functions, and graphs, right? So let's begin. All right. So the first thing we need to talk about is something called relations, right? And a relation is a set of ordered pairs that obey a particular rule. All right. So for example, let's say we have something like this, right? And we have, let's say, 1, 2, 3, 4. And we have another set here, right? This diagram that I'm drawing here is what we call a mapping diagram, right? And we have 2, 4, 6, and 8, all right? And we have 1 is mapped onto 2, 2 is mapped onto 4, 3 is mapped onto 6, and 4 is mapped onto 8, right? So this is what we call a mapping. So this here is one set, right? And this here is another set. Now, this first part here is what we call, or this list of numbers here is what we call my domain, right? That's a special name for my domain. Those are the numbers 1, 2, 3, and 4. And this here is what we call the codomain. All right. Now, first thing I said a relation right is a set of ordered pairs that obeys a particular rule. So that is what a relation is, right? So you need to understand the concept of a relation. So on the left hand side we have the domain, on the right hand side we have the codomain, right? Now the values on the left, right, are what we typically call the x values, right? Now this word here, a set of ordered pairs, you all need to know what this means, right? A set of ordered pairs looks like this. So we see that 1, the number 1 is mapped onto 2, right? So we can write that as 1, 2. We see that 2 is mapped onto 4, so we can write that as 2, 4. We see that 3 is mapped onto 6, and we see that 4 is mapped on to 8, right? So what I've written here is what we call a set of ordered pairs. So this here, right, is what we call a set of ordered pairs, right? Now, I believe it was the May 2018 paper, they asked a question relating to ordered pairs and students didn't know what they were talking about, right? So what I'm showing you here, we have something called a relation. It's just a set of ordered pairs, right? And the set of ordered pairs here in this case is all of this. This here is my set of ordered pairs, right, for this particular mapping. Now we also said that a relation, you have a particular rule, right? Now if we look at all the numbers on the left hand side and all the numbers on the right hand side, we can write the rule as x does this, 2x, right? What that means is that if I take this one here, and I multiply, I'm looking at this is the rule here, we say the rule is 2x. 2 multiplied by 1 will give me 2. Then 2 multiplied by 2 will give me 4, right? And give our next one here. If we have 3 multiplied by 2, we're going to get 6. So you realize that there's a clear rule that maps my domain to my codomain, right? I hope you're all following so far. Now I'll give you a next set of numbers here. Let me give you a next relation, right? So let's say we have 1, 2, 3, 4, right? And then that is mapped on to my codomain here, which is, let's say, 3, 4, 5, and 6, right? So we're saying that 1 is mapped onto 3, 2 is mapped onto 4, right? And we're saying 4 is mapped onto 6, right? And this here, so what I want to know what is my relation between my domain and my codomain, right? There is a relationship. So let's go to the chat and let me see what you all think. So it's gonna look like x this, and I want you to give me what is the relationship between my domain and my codomain, right? I'll give you what the set of ordered pairs are. So the set of ordered pairs, right? We start off with this and we say 1 is mapped onto 3, 2 is mapped onto 4, 3 is mapped onto 5, and 4 is mapped onto 6. Right? So this is my set of ordered pairs. What is the relation? That's what I want to know. So I want you all to type your answer in the live chat. Okay? Any answers? Any thoughts? Alright, so I'm seeing x plus 2. That is correct. So there is a relationship. If you look at something here, right, 1 is mapped onto 3. The relationship is this, x plus 2, right? Because look at this, if I have 1 and I add 2 to it, I'll get 3. If I have 2 and I add 2 to it, I will get 4. If I add, we have this, and we add 2, we're going to get 5. So the relationship is x plus 2. All right? Now, this diagram that I've drawn here, right, with the domain and the codomain, it's called a mapping diagram. Now, we have different kinds of mappings. All right? So, let's talk about mappings. Right? So the first one we're going to look at is something called a 1-to-1 mapping. Right? Now this is what a 1-to-1 mapping looks like. Let's say we have 1, 2, 3, 4, and we have this here, 5, 6, 7, 8, right? Now this here is what we call a 1-to-1 mapping, right? Because every single element in the first set in my domain maps to one element in my codomain, right? So 1 maps onto 5, 2 maps onto 6, 3 maps onto 7, and 4 maps onto 8. So this is what we call a 1-to-1 mapping, right? This is what they call a 1-to-1 mapping. We have something else called a many-to-one mapping. Let's go with the many-to-one first, right? So many-to-one mapping, right? So a many-to-one mapping might look something like this. Let's say -1, 0, let's say 1, 2. Let's put a -2 inside here. All right, and we have something like this: 0, 1, and 4. All right. Right? This relation is what we call a many-to-one mapping, right? Because if you look at something, let's say this number here, 4, right? We have 2 numbers that are mapped from it, right? So -2 maps onto 4 and 2 maps onto 4, right? If we look at the 1, we have -1 is mapped onto 1 and 1 is also mapped onto 1, right? So this mapping is what you call a many-to-one mapping. All right. So this is another kind of mapping. It's called a many-to-one. Right. So you all follow me so far? So we just looked at 2 types of mappings. One is called a 1-to-1 mapping. The next one is called a many-to-one mapping. We have 2 more we need to look at. All right. So this next one here is a 1 to many mapping. Right, so you have something called a 1-to-many mapping. Right. And what I will do, I won't put numbers here, right? Sometimes in the exam they give you something like this. They use this to represent numbers, right? Let's say we have something like this, right? We're assuming these represent numbers, right? And it might look like this, this, or you might see something like this, right? This is what we call a one-to-many mapping. Notice, let's say from this here, right? For this one, you have this number here being mapped onto this, to this, right? And to this, right? So that is one going to many in the codomain. Again, if we look at this number here, we have this being mapped onto this. It's also mapped onto this, and it's also mapped onto this, right? So this is what you call a one-to-many mapping, all right? And then the last, so this is the third type, a one-to-many. And this is the last one here, which is called a many-to-many mapping. Right, so this one looks like this. Again, for this one I won't put any numbers. Right, so right, so a many to many will look something like this. This might be here, this might be this, this might be this, right? Or we can have this coming here, this coming here, right? Or you can have this coming here, or you can have this coming here, right? So a many to many mapping, right, may look something like this, all right? So many elements in the domain map to many elements in the codomain, all right? So I want you to keep in mind there are 4 types of mappings, right? In the exam, they can ask you about these things, right? They can draw what we call a mapping diagram, and they will ask you which of the following best describes this mapping diagram, all right? So make sure you know all 4. So the first one was a one-to-many, then we had a many-to-one, right? Then we had one-to-many and something called many-to-many. All right, now let's go back here. Now sometimes, all right, now actually I'll come back to that. Let's talk about a function now, right? So all we've been talking about relations, right? But we have something called a function, right, in maths. Now, so what is a function? So a function, right, is a relation. So the function is a relation, right, in which each element in a domain, in which each element in the domain is mapped onto one, and only one element in the range, right? So each element in the domain is mapped onto one and only one element in the range, right? So this is the definition for a function. They're not going to ask you this in the exam, right? They're not going to ask you that in the exam. So what does that mean? So it means that a function, right, can only be a one-to-one mapping and a many-to-one right? So you notice I gave you 4 different types of relations, but only 2 of them are actually functions. So if I go back here, right, that's why I did these 2 first. These 2 here, right, this is a function, and this is also a function. The other 2 are not considered functions, right? Now let's talk about something here. How to tell if something is a function. Right? How do we tell if something is a function? Now, in the exam, especially in the multiple choice exam, they can give you a graph, right? A graph that looks like this, where we have y and we have x, right? And they come and they give you a graph. The graph looks like this, and they come and they ask you, is this graph a function or not, right? Now, to know if a graph is a function or not, we have to do something. We do something called a vertical line test, right? That's what we're going to do. So when you are given a graph, what you need to do is to draw a vertical line, right, along the graph and see that they only intersect at one point. Look at this here. You're intersecting at one point, right? If I do this, I'm intersecting at one point. So this here is a function, right? Let's look at the next graph. If we have this, right, and the graph looks something like this, which I've spoken to you in class about, it's called a quadratic, right? And I want to do a vertical line test to see if it's a function. If I draw a vertical line here, it only intersects at one point. If I draw a vertical line here, it intersects at one point. If I draw a vertical line here, it intersects at one point. So therefore I can see that this is a function, right? If, however, I give you a graph that looks like this, right, this is y and this is x, and I try to do a vertical line test on this, right, I do this, you're going to realize that it intersects at this point and this point. So this is not a function, right? So we use a vertical line test to determine if something is a function or not, right? Let me give you one more example that I've seen them bring. Let's say we have a graph like this, and the graph looks like this, and we want to determine if that is a function. You draw a vertical line. Look, it's going to intersect here and intersect here. If we draw a vertical line here, it's going to intersect here and intersect here. So again, this is not a function. All right, so let me just pause there and let me ask you all if you all are okay. Are you all following? So can you all just type your names in the chat so I know all who's here? I mean, I'm seeing some of you all. Emily, right, so Emily's here. Emily, Cherise, Danica, Tamika, okay, so this is Chad. All right, so let me continue. All right, give me a sec there. All right, so graphically in the exam, if they ask you to determine if something is a function, we do a vertical line test, right? So let's move on to something now, right? Let's move on to how the exam questions actually come. How do we represent a function, right? So a function, right, could be represented as, look at this statement. So I can represent a function like this, all right? And you all need to understand the language that we use for this. So here's how you read this. So f, right, you see these two little dots here, is such that, right, this here, such that x, and this arrow you're seeing here, maps onto x plus 1, right? So you need to understand the language that I'm using here now. So how are we going to read this? Let's make sure we have this clear. So we say that f, this, the two dots represents, is such that x, right, maps onto 2x plus 1, right? That's how we represent a function, right? There's another way we can represent a function. We can represent a function like this. So if we look at that same function, you can see it being written as f of x is equal to 2x plus 1, right? So this is one way we can represent a function. This is a second way we can represent a function. Both ways it can be given in the exam, right? Now, let me give you an example as to how we're going to work with this. So let's say I have given you a function f is such that x maps on to, let's say, 2x plus 1, right? So there's a function they've given you, and they want you to find f of x. I'm sorry, not f of x, f of, let's say, 2. Right, sorry about that. Yeah. So they want you to find f of 2. Alright. Now I want you to visualize this as a machine. Alright. We have a machine. We're going to put something into the machine and something is going to come out. right? The values that we put into the machine, right, or the set of values we put into the machine is what we call my domain, right? Those are the set of values that goes into the machine. And what comes out of the machine is what we call the range, right? That's a new term. A range is simply a subset of my codomain, all right? So all I want you to remember right now, with a function, right, we have the values that we're going to put into the function, that is called my domain, and the values that come out of the function is what we call my range. Now, this question here, it's asking, what is f of 2? Now, here's how you write your solution for this. So the first thing we should do is to write this. F of x is equal to 2x plus 1. That is my function. The question is asking, what is f of 2? Right? F of 2 means that I'm going to plug 2. So 2 is going into my function and something is going to come out. What I'm going to do, I'm going to say x is equal to 2. So it's going to be 2 multiplied by 2 plus 1. So this will give me 4 plus 1, which is 5. So therefore f of 2 is equal to 5. So my output of this function is 5. Alright? So when they give you a question like this is how you write in the answer. Let's say I ask you, I want to find f of minus 4. Right? I want to find f of minus 4. So you want to find f of minus 4. Let's call this A. Let's call this B. Right? So this here was the answer for A. Let's work B on the side here. Alright, now we always start off by writing what the function is. So f of x is equal to 2x plus 1, and I want to find f of what are we doing? F of minus 4. Right? So you want to find f of minus 4. Again, what we're going to do, we're going to take minus 4 and substitute it into the function. So anywhere we see x, we're going to put minus 4. So this is going to be 2 by minus 4 plus 1. So 2 by minus 4 gives me minus 8 plus 1. So therefore minus 8 plus 1 gives me minus 7. Alright? So therefore f of minus 4 is equal to minus 7. Alright? So this is the typical function question they're going to ask you. They're going to give you some values of x, and they're going to ask you to find what is the range, right? Now, let me give you something else. So let's say we have f of x. I'm going to write the function as this. F of x is equal to let's say x minus 4, right? This is my function. F of x is, we're going to say where x goes from, let's say, minus 1 to, right? Give me a second, something's alright. So let's say we have this, right? So they've given us a function. The function is defined by this. F of x is equal to x minus 4, right? And they're giving us a piece of information here. This here, right? This piece of information here is what we call the domain of the function, alright? So in the exam, you can see something like that. They can say a function is defined by this, and they've given us the domain. And they will come and they will ask you, find the range of the function. right? So in the exam, they can ask you this. So how do we do this now? Now we know what the function is. The function is x minus 4, and my domain is going from -1 to 3. So my domain, right, goes from -1, 0, 1, 2, 3. Right? And you want to find the range. All we need to do is to substitute each of these values here into the function, right? So let's plug in -1 into the function, and I'm going to get -1 minus 4 is -5. Next one's going to be 0 minus 4. I'm going to get -4. Next one is going to be 1 minus 4, which is -3. The next one is 2 minus 4, which is -2. The next one is 3 minus 4, which is equal to -1. So these values here, right, represent my range. So my range, right, for this function, and I'm going to write it in a set format. So I'm going to put the open curlies, right, and it's going to be, let's put them in numbers like this. So we could say -5, -4, -3, -2, and -1, right? So this here is actually what my range is. So in the exam, they can give you a function, they can give you what the domain is, and then they can come and ask you, hey, what is the range? Right? So you all followed me so far? Don't want you all to get lost. Alright, let me see something here. So I'm looking at the comments. Danica is saying we started doing this at school last week. Shuri is saying we did it last term but gave a little trouble. Alright, so no problem, we'll sort that out. Alright, so alright, let me give you our next question here, right? So let's say we have f of x is equal to x minus 1, and we have g of x equal to 2x plus 3, right? And I want you to find a f of 1, b f of minus 4, c f of 0, d g of 0, e g of minus 2, and f of 2 plus g of 1. Alright, so I've given you two functions. One is f of x and the next one is g of x. And I want you to find, so let's work on this together, right? So we're going to start with the first part A. So let's start with this one. I want you all to try to work it out. Let's see what you all get into the answer, right? Alright, you all can type the answer in the chat. Let me see what you all get in. Alright, so I'll wait. Alright, so I was just trying to find out if Ryan and Alex in the class. I wasn't sure. I'm seeing some answers and seeing people getting 0 as the answer. Let's look at that. So we want to find f of 1. So f of 1 is straightforward. F of 1 is equal to, remember the function is this, right? This is the function here. So f of 1 will simply be 1 minus 1, which is 0, right? So let's work out the next one. Let me get an answer for f of minus 4, please. So Cherise get minus 5. Is that correct? Let's see. F of minus 4 is equal to minus 4 minus 1, which is equal to minus 5. So yes, Cherise, that is correct. Alright, so the next one is f of 0. Alright, let me just see what you all put in there. Alright, so I see in minus 1, that is Danica. Alright, so this is 0 minus 1, which is minus 1. So that's correct. The next one we want is g of 0. So what are you all getting for g of 0? Alright, so I see in Tyrell 3, Emily 3. Let's see what's the answer for that one. So g of 0 So this will be 2 multiplied by 0 plus 3. 2 by 0 is 0 plus 3, and this will give me 3. Alright, so yes, the answer is that. The next one is g of minus 2. Let me hear what you all get for that one. Alright, so I'm seeing minus 1. Let's see. So g of minus 2. G of minus 2 is 2 by minus 2 plus 3, which is equal, 2 by minus 2 gives me minus 4 plus 3, which gives me minus 1. Alright, so yes, the answer is minus 1. And the last one, right, which is another way they can ask the question, they are asking what is the answer for f of 2 plus g of 1. Right? Now, it only looks complicated. It's not really complicated. You just need to find f of 2 first, and then find g of 1, and then add those two answers. Right? So, f of 2 will be equal to 2 minus 1, which is 1. G of 1 is equal to 2 by 1 plus 3, which is equal to 2 plus 3, which is equal to 5. So therefore, f of 2 plus g of 1, right, is equal to 1 plus 5, which is equal to 6. Alright? So we okay there? These are some of the straightforward questions they could ask on functions, right? I'll start doing a little more complicated ones in a little bit. Now, everybody okay? We good? Alright, so let's move on to something else, right? Now, let's talk about something called the inverse of a function. Alright, now I gave you all a diagram before. I said, think of a function as a machine. Right? We're going to put in x values, right? And we're going to get values coming out. Sometimes we call it y values, or we can say f of x, right? So a function, right, takes x values and it spits out something. Now, so if I put a number here, right, something is going to come out. Something is going to come out of the function, right? But if I want to do the reverse process, if I want to take that value here, this green value, and I want to go back this way, right? There is a function that will allow me to do that. That function is written like this: f inverse of x. And this function here, right, it's called my inverse function. Right? So that is what we call my inverse function. So in the exam, they can ask you to draw, to determine what is the inverse function, right? So the question will be either find the inverse, or they will say find f inverse of x. So that is what we call the inverse of the function, right? Now there's a procedure that we do to do that. But before I forget, let me show you something here, right? So the relationship between a a function and its inverse, right? So one mark thing you get in the exam sometimes. So let's see, I have a graph, right, that looks like this. This is x and this is y, all right? And let's see that we have a function here, and that function is called f of x, right? There is a relationship between a function and its inverse, right? And we can do this graphically. If I were to draw the line, if I draw in this line here, this line here, right? Let me just extend it a little more here. That line is the line y equal to x, right? So that's the line y equal x. Now, there's a relationship between a function and its inverse. To get the inverse of the inverse function is a reflection in this line here, this line y equal x, right? Which looks like this dashed line here. So if my inverse is a reflection of that, the inverse function is going to look like this. Right? So visualize me putting a mirror along that dashed line, the line y equal x. And when I reflect the function, right? So let me just, hold on. Let's see. So let's make sure we have this clear, right? So this here, the red line, this red line here is f of x, right? And this green line is what we call f inverse of x, right? So the relationship between a function and its inverse, right? It's a reflection in the line y equal x. All right, so this is something that you need to know, right? I'm not going to spend too much time on this. You may see this in the multiple choice exam, or it may come as a question, right? Okay, so let me explain how to find the inverse of a function now. So if we have, if f of x is equal to, let's say 5x minus 2, and you want to find, now this is a typical exam question, find f inverse of x. How are you going to do that? So to find the inverse of a function, there are a series of steps that we must follow, right? So so the first step, when they give you the function, your first step is to do this. You say, so this is step 1. We let y equal 5x minus 2. That's step 1. So whatever the function is, we're going to say let y equal to 5x minus 1, right? So all you're doing, you're replacing this. That's all you do. That's my step 1. You have a second step now. Step 2. We must interchange x and y. Now what does that mean? It means that anywhere we see x, we're going to put y, and anywhere we see y, we're going to put x, right? So if we look at this equation here, that's this one here, what is going to happen is that x is going to be equal to 5y minus 2. So anywhere I saw x, I would put y, and anywhere I see y, I'm going to put x, right? That's my next step. Your third step now, right, is to make y the subject of the formula. That's the next thing we need to do. As the third step, you have to make y the subject of the formula. So look at the equation we have. We have x is equal to 5y minus 2. So if you want to make y the subject of the formula, what that means is that we're going to make y equal to something, right? So what I would do, I would say 5y minus 2 is equal to x. Hope you're all seeing that, right? If x is equal to 5y minus 2, then we can say 5y minus 2 is equal to x. Because I really want y equal to something, right? Then we need to move the minus 2. This becomes 5y is equal to x plus 2. Now remember, in class I keep telling you all proper statements are important. Please make sure that your equal signs are under equal signs, right? If you lay out your answer properly in the exam, you're going to be okay. So we have 5y equal x plus 2. So therefore y is equal to x plus 2 over 5. Right? Now, we just have one more step to do again, right? And we're finished. So I can fit it on the side here instead of going to the next page. So step 4, we need to write we need to write this. So my final answer, let me use a different color here. We're going to say that f inverse of x is equal to x plus 2 over 5. Alright, so that is my inverse of this function. Right? So essentially there are 4 steps in order to find the inverse of a function. Okay? So what I want you all to do now, I want you all to do one for me. So f of x is equal to two x minus 3. Find f inverse of x. Alright, so I'm going to give you all a few minutes to work this one out, right? And you all could type your answers in the chat. Alright, so I'll give you a few minutes to try this one. Alright, so I'll give you all a few minutes. I'm just going to put my mic on mute for a second, okay? Alright, so I'm seeing some answers coming in here. I'm seeing x plus 3 over 2. Alright, so let me start the question. So my first step, I said the first thing we do, we let y equal 2x minus 3. Now I've numbered the steps for you, right? But we can just go ahead and, so we could say let y equal 2x minus 3. Then we need to, next step is to interchange x and y. So interchange x and y. So therefore, anywhere we see x, we're going to put y, and anywhere we see y, we're going to put x. So this is going to be x is equal to 2y minus 3. And the next step is to make y the subject. Right? So therefore, what I will do, I'll write 2y minus 3 is equal to x. So 2y is equal to x plus 3, and therefore y is equal to x plus 3 all over 2. Right? So therefore, my last line, or my last step, I'm going to write f inverse of x is equal to x plus 3 over 2. Alright? So this is the answer I'm seeing you all getting. Alright? So it is x plus 3 over 2. Alright, so that is what we call the inverse of a function. Now, apart from finding the inverse of a function, we have something called a composite function. Right? So that's something called a composite function. So for example, let's say we have f of x is equal to, let's say x squared, right? And we have g of x equal to x plus 1. And I come and I ask you, find fg of x. Right? I've asked you to find fg of x. Now, lots of students, they get confused with what this really means. Alright? Now, here's how you're going to read this. You're reading this function from your right hand side and then going to the left hand side. So what you're going to do, you're going to say, you're going to take the g of x, right? And I'm going to plug that into the function f. Right? Sounding simple enough, right? But some students have problems with this. So what I'm going to do, I'm going to take whatever the function g is and I'm going to plug it into the function f. The function g is this whole thing here, x plus 1. So I'm going to take that whole x plus 1 and I'm going to plug it into the function f as x plus 1. Right? So this is what we're going to do. I'm going to take this whole thing here, this whole x plus 1, and I'm going to plug it into this function here. Right? So this is going to be x plus 1 squared. So fg of x is x plus 1 squared. Right? Now I know this could be a little confusing. So let's do something else here. What if I want to find g f of x? Right? If you want to find g f of x, again, same concept. I'm going to take the function f and I'm going to plug it inside of g. Right? That's what you're doing. So the function f is this. It's x squared, right? Is this. So I'm going to take this number now, or this variable, and plug it into the function g. So what that is going to be, it's going to be x squared plus 1. Alright, so notice how we find fg of x and how we find gf of x. So those are what we call composite functions. Right? So just get one for you to do here. What if we have so let's say I have f of x is equal to, let's say, x squared, and g of x is equal to 2x minus 1, right? So I have f of x equal to x squared and g of x equal to x minus 1. And I want to find, first thing I want to find is fg of x, and then for part b I want to find g f of x. Right? So I'll give you a few minutes to work out both of them. You want to find fg of x and gf of x. So I see Tamika's answer, Darrell, 2x minus 1 squared. I'll wait to get some more answers. Alright, so I see Emily has the same thing as well. Alright, so let me work the first part, right, while I wait for the answer for the second part. Alright, so here's what we want to do. So the first one, we want f g of x, right? So like I said, we're going to take g and we're going to plug it into the function f, right? Now g is really 2x minus 1 and I'm plugging it into f. So it's going to be 2x minus 1 all squared, right? And that's it. That's the answer, right? You're only going to have to expand this if the question asks you to expand it, right? So we'll just leave it like that for now. And for part B, you want to find g f of x, which is equal to, let's see if you all put anything there, 2x squared minus 1. Let's see if it's that. So what you're going to do, you're going to take f of x and I'm going to plug it into g. So f of x is this and I'm going to plug it into g. So the answer is going to be 2x squared minus 1. Alright? Alright, so this is how we find the composite functions when they give you more than one function. Alright. So let me see. Can you all look at a question, actual exam question as yet? Hold on one sec, right? Alright, so this is an actual exam question. This is actually January 2004, I believe it is. Yeah, January 2004, right? So they've given us two functions here. They've given us f of x and g of x, right? So we have f of x is given by this and we have g of x is given by this. Alright, so the first part of the question, they want g of 25. So we want to find g of 25. Can you all tell me what g of 25 is? Alright, so I've seen some people saying 5, right? I think that's correct. So you want to find g of 25. I'm going to take 25 and plug it into the function g. Alright, so what we need to do is to find the square root of 25 and you're going to get 5, right? Now, I want you all to remember something. When you find the square root of 25, square root of 25 is actually plus or minus 5, right? Because if I take 5 and I square it, I'm going to get 25. If I have minus 5 squared, I'm still going to get 25, right? So the square root of 25 is actually plus or minus 5. Now, usually what CXC will do, they will ask you for the positive value or the negative value. Just read the question and that will be a guide. So for now, we'll just put the answer as 5, right? Then the next part now, they want to find g f of 15. Now let me show you how to do this question, right? Now, there are two ways we can do this question. We can either find the function g f of x, we can find that first, right? Yeah, we can find g f of x first, right? And then just substitute 15 into that answer, right? Now, there's an easy way to do this. The first thing we do, because we say we usually work this out first and then we plug that into this. So what you should do is to find f of 15 first, right? So if we find f of 15, it's going to be 3 multiplied by 15 plus 4, right? And 15 times 3 is really 45 plus 4, which is equal to 49, right? So that is f of 15. Now, what we're going to do now is take this answer here, the 49, and we're going to plug that into g. So we're going to find g of 49, right? But remember, this is the function g here. So this is the square root of 49, which is equal to 7, right? So therefore, g f of 15 is equal to 7. So I did this question via 2 steps here, right? So I worked out f of 15 first, I got this answer. Then I took that answer and I plugged it into the function g. And that's how I got 7, right? Right? So the alternative to this was to find this first, find gf of x, and then plug 15 into it, right? But for some students, this method here is much easier, right? So first thing you do, you find f of 15, and the next thing to do, the answer you got, you plug it into the function g, all right? So that is January 2004, right? Let me get our next question here. I just want to do a few actual questions first, so you get an idea as to how to answer these questions before I give you one to do. Alright, give me a sec. Let me just... Oh, okay. So, there's one more thing I just need to show you quickly. All right, let's see. Actually, we can do this question. Hold on. So I have this here. Alright, so here what to do for me. I want you to attempt this question, parts 1 and 2. I'll give you some time to work it out. Alright, so this is, this paper is, what year is this by? Alright, so this is January 2005. Alright, so this is January 2005. Alright, so they've given you two functions. So I want you to work out part 1, 2, and 3 for me. Okay, I'll give you a few minutes to work that out. Alright, I'm seeing some answers coming up. That's for the composite function. Alright, so I'll wait till you all reach the end of the question. That is for the inverse part of it before I work it. For the third part, where we have the inverse, please find the inverse function first and then substitute 7 into the inverse function. Okay? So I'm waiting until I get at least one answer for the last part, and then I'll start to work it. Alright, so I'm seeing some answers for the last part, so let me try to work it for you all. So they've given us two functions, f and g, right? And they want us to calculate the value of g of 4. So g of 4, all we need to do is to substitute 4 into this function here, right? Which is equal to 2 multiplied by 4 minus 3, which is equal to 8 minus 3, which is 5, right? So the answer for part 1 is simply 5, right? That's a straight substitution. Then for part 2, we have fg of 2. So you're going to take g of 2, and you're going to substitute into f, right? So the first thing we need to do, we need to find g of 2, right? So let's go. G of 2 is equal to 2 by 2 minus 3. So this is 4 minus 3, which is 1. Now that answer, now we're going to take that answer and substitute it into f. So we're going to find f of 1, right? So this will be 2 multiplied by 1 plus 5 all over 1 minus 4, which is 2 plus 5, which is 7, over 1 minus 4 is minus 3, right? So it's really minus 7 over 3, right? So some of you all got that. So the answer for that is minus 7 over 3. Alright. Then the last part now, g inverse of 7. So the first thing I will do, I will find the inverse of the function, this function here. So we have g of x equal 2x minus 3. My first step is to let y equal 2x minus 3. Right? The next step is to interchange x and y. So this is x is equal to 2y minus 3. So therefore 2y minus 3 is equal to x. So 2y is equal to x plus 3. So y is equal to x plus 3 over 2. So therefore my inverse of this function, in this case we're finding the inverse of g of x, right? So I'm going to say g inverse of x is equal to x plus 3 divided by 2, right? But the question wants us to find g inverse of 7. So therefore all we need to do is to say g inverse of 7 is equal to 7 plus 3 over 2, which is equal to 10 over 2, which is equal to 5, right? I think some of you all, yeah, so some of you all got, well, Daryl got 5, all right? So the answer for this part is actually equal to 5, all right? So again, there's a typical exam question. Let me get our next question for you all to try. Hold on a sec. Alright, so I have a next one here for you all. This one is January 2007. Alright, so we have two functions, f and g, and they want us to find certain things. So I'll give you a few minutes to work this one as well. Alright, now let's put the mic on mute for now. Alright, so see you all getting through the problems. I'll give you a few minutes again. Alright, so I'm gonna try to do this here before we wrap up, right? Okay, so they're giving us two functions, f of x. Now notice how they wrote it this time, right? F with the two dots, right? So they've given us two functions. The first part, they want us to find g of 3. So g of 3 equal, you're gonna plug 3 into the second function. So that's 1 over 2 multiplied by 3, which is 1 over 6, right? I didn't check to see if you all got that. Yes, you all had 1 over 6, so 1 over 6 is correct. So g of 3 is 1 over 6, right? The next part is f of minus 2. So I'm going to find f of minus 2 is equal to 7 multiplied by minus 2 plus 4, which is equal to minus 14. 7 2s are minus 14 plus 4, right? And that will give us minus 10, right? So this one here is minus 10. Let's see what you all got. Alright, so see Josiah had minus 10, Tamika minus 10, Danica. Alright, so most of you all got minus 10. And the last part now, you want to find f inverse of 11, right? So we have the function f. So the first thing we're going to do is to let y equal to 7x plus 4, right? And then we're going to interchange. When you interchange, you'll end up with x is equal to 7y plus 4, right? We're going to write 7y plus 4 equal to x. 7y is equal to x minus 4, and therefore y is equal to x minus 4 divided by 7. So therefore f inverse of x as the inverse function is equal to x minus 4 divided by 7, right? But the question wants us to find f inverse of 11. So all we need to do, f inverse of 11, we're going to take the 11 and substitute it into this here. So this is 11 minus 4, right, over 7. So that is 11 minus 4 is 7 divided by 7, which is equal to 1. Right? So f inverse of 11 is equal to 1. Right? So some of you all got that. All right. So so basically this is our first session online, right? So indefinitely our classes will be online from now on, right? Based on the current situation, right? There are some advantages to doing it online. I mean, you don't have to travel to come to class. You don't need to hustle, right? You're doing this from your comfort at home. You can relax, watch your videos. You can also replay the videos, right? So the same link that you use to join the class, you should be able to access the video, right, sometime later, right? So I hope that we had a productive class, right? If you all have any questions, please just type it in the chat before we wrap up. So Sharice is saying she loved the session. Should be like this on a whole. Yeah, well, we'll see we'll see how things go. All right. All right. So I'll see you all next week. All right. The Form 5 class is on Thursday. Form 4 students, you're all free to come in and listen in the Form 5 class. That's no problem, right? Because it's not a physical space, right? So, all right. So until next week, you all take it easy, right? Take care. Please be safe. Wash your hands. Try not to go out anywhere, right? Take your vitamins, all right? Just now, Darrell's asks, so come you put, right, it doesn't make a difference because you can either write it, there are two different ways of writing the function, right? So don't worry, I will send some more questions for you all to practice, right, before the next class, right? In case I forget, because I'm a little busy, just remind me, okay? So you guys take care, all right, until next week.